let's take a look at some applications of quadratic functions. Okay, so this first example, we want to find the dimensions of a rectangular corral producing the greatest enclosed area given 200 feet of fencing. Okay, so what I know about this rectangular corral, it would have a length and a width. And I do know that the perimeter of a rectangle is 2 times the length plus 2 times the width, and the area is the length times the width. In the case of this example, the perimeter, or the distance around this rectangular corral, is given as 200 feet. And why don't we solve this equation for L or W, whichever variable you would like. I'm going to solve it for L. And to do that, I'll first subtract 2W from each side, and then divide both sides by 2. And we find that L is equal to 100 minus W. At this point, we notice that the goal is to find the greatest enclosed area, or find the dimensions of the rectangle that will produce the greatest enclosed area. So we're going to replace L with this other expression involving W, 100 minus W. And we find a quadratic. A is equal to 100W minus W squared, or negative W squared plus 100W. And if you imagine sketching the graph where W is the independent variable and A is the dependent variable, it would look something like this, with a maximum value at the vertex. And so I think that's what we're planning on finding. Okay, to find the location of the maximum, we're going to use the vertex formula. H is equal to negative B over 2A. And that's negative 100 divided by 2 times negative 1, or just 50. Now I refer back to the question. It says find the dimensions of the rectangular corral. So what we found, an H value, is actually a W, because it's the first value in our ordered pair, and our vertex is of the form H, K, but in this case it's W, A. So we know a width is 50, and we need the corresponding length. And to find it, we're going to go back to our formula that we made earlier, which is for the length in terms of the width. And so L equals 100 minus W, in this case 50, or 50. So the dimensions of this given corral should be 50 by 50 in order to maximize the area. And let's take a look at another example. A ball is thrown in the air from the top of a building. Its height in meters as a function of time in seconds is given as h of t is equal to negative 4.9 t squared plus 24t plus 8. In the first part of the question, it says, how long does it take to reach maximum height? Okay, so you can imagine what the graph of this function looks like, that it's a parabola that opens downward, and it has a y-intercept of 8, and so without knowing a whole lot about the graph, we could say something like this, where time is plotted on the horizontal axis and the ball's height is on the vertical axis. We want to know how long it takes to reach maximum height, so essentially we're just finding the location of the vertex. Okay, well, how to do that is we'll find h, k which is the x-coordinate of the vertex and the y-coordinate of the vertex. And if you recall, h is equal to negative b over 2a, and b in this formula is 24, and a is negative 4.9. So we have negative 24 divided by 2 times negative 4.9, which is approximately equal to 2.45. Okay, now let's imagine what this point represents, what this h value represents, which is the x-coordinate of the vertex, and that's of the form t comma h. And so the x-coordinate of the vertex is a time, and therefore this is in seconds. And it answers the question, how long does it take to reach maximum height? In the second part of the question, we're asked to find when the ball hits the ground. So recognizing that this parabola represents the height of the ball over time, ground level is down here on the t-axis. In other words, it's a t-intercept, and that occurs when the height is 0. So just substitute 0 for h, and then we'll solve the equation. If you recall, we have various methods for solving a quadratic equation. One is factoring, another is completing the square, a third, which may be the route we'll take, is using the quadratic formula. So we first determine a, b, and c, and a is negative 4.9, b is 24, and c is 8. And then we'll substitute those values into the quadratic formula. Okay, so negative b, that's negative 24, plus or minus the square root of 24 squared, minus 4 times a, negative 4.9, times c, which is 8, divided by 2 times a, which is negative 4.9. And then we want to simplify this as much as possible. And I'll start with a radicand. Okay, so I have negative 24 plus or minus the square root of 732.8 divided by negative 9.8. And now we're going to just take this expression and evaluate it. So with addition in the numerator, we get t is approximately negative 0.31. Okay, instead, if we use the subtraction, it's negative 24 minus the square root of 732.8 divided by negative 9.8, which is approximately 5.21. Okay, and we want to know how long it takes to hit the ground, and so we need a time that's in the future, and that happens to be the second answer that we found, so 5.21 seconds.